Hello friends, and apologies, it's been a while since our last little video. I've been travelling in the US of A, but I'm here now and it's gorgeous summer weather I've returned to, so I'm sipping on a cool glass of Diet Iron Brew. Lovely. And there's nothing better to lubricate your throat when you're making a kit. And this is a kit from Amazon, and it's not sponsored, by the way, if ever you go, oh, is he sponsored? No, I'm not sponsored by Geek Fun. Although maybe I should be, because look, it actually has a proper colour manual. So this apparently is the CHA81 LED Chaser Kit, which I don't really know what it does. It's some sort of thing that illuminates the LEDs in the pattern, and oh by gosh, look at that. It looks like it's two CD4017s, which I don't know what they are, but maybe they're some sort of decade counter or similar. In fact, I would suspect they are a decade counter. And then you've got two 555 timers. So one is like the outer limits. It's in charge of both your horizontal and your vertical, and by adjusting the potentiometers here, you see you've got two here, you'll be able to adjust the speed of the sweep, and then between the two you'll be able to make it go in different directions. I don't know if it'll do a sinus, probably not, but this would be a great start actually for a really interesting kit, you know, if you're going to actually play with these things. I'm just looking here. So when you have these decade counter type things, and again, apologies if it isn't a decade counter, but just pretend it is. Basically what happens is, every time you get a pulse from your output on your NE555 or any other kind of input that's triggering this, it will output a different channel, yeah? So it's going to start on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you can see 11 isn't connected to any kind of LED via transistor. It's going off down here, and you can see here either it's powering directly the input of the other decade counter, or it's acting as some sort of trigger on this NE555. And I don't really know how NE555s work 100%. In fact, I don't really know 1%. But you could see it's going to affect how this illuminates. Now, some of these do like a hold, where it'll be output 1 will be on, and then output 2 and output 3. And then some of them just do one at a time. So I don't really know. Again, either way, between the two, you're going to get interesting patterns. And you'll be able to do your own Doctor Who type effects. So let's see what we've got in the bag. A rather nifty board. Look at that. That is absolutely quality with a capital Q. That is pretty nice. A CHA81. It's all written on the board and nicely silk screened. A huge bag of LEDs. And of course, if you've got LEDs at home, you could substitute them. And a USB power cable. So there's not really much more you can say about that. It's a kit that literally just cost 12 quid. Let's see how many flavours of resistor you've got. You've only got 3 kinds of resistor, so that's nice and simple. And you could see from the diagram again, I do apologise for jumping back and forth through the diagram. You could see that the base of the transistor is coming from your decade counter, and that will be a kind of in a matrix configuration, won't it? So if the LED is going to be illuminated, so power will come through this transistor to this line, so it will power this line, and then the LED will be illuminated if this line is connected. So it does need a combination of both the horizontal and vertical to sort of close up, as it were. Let's keep going. Lots of LEDs, lots of transistors. Now I think, looking at the schematic, which is just off camera, that it's calling them triodes, which are the transistors, but they are all the same, so you can't really go wrong on those. So I think I'm just going to pick out all the parts and put them in their little piles, and then we will begin. All the parts are laid out for us now. We have resistors, and these are the 10K. These are the 220R, that's 220 ohms, and this is the 3.3K. We have 2 potentiometers, 4 switches, 1 power jack, 3 types of capacitor, 2 the same, bunch of LEDs, our 2 counter chips, our 2 555 timer chips, 3 capacitors, 2 again being the same variety, our transistors, and our USB lead. So we really can't go wrong. Now looking at the board, I would suggest we start at the middle, and that's loading our LEDs in there. So when you're playing with your LEDs, of course, make sure you put them in the right way. And let's see if this tells you. It is actually long leg positive, but interestingly enough, it doesn't get to the LEDs until you've already put in the resistor. So they're starting with the lower components and then working their way up. I don't see there's any harm following that. Let's do that. That's fine. So they're literally saying step 1, do the R1, which is the 3.3K resistor. So pop that in. Now I did have a bender somewhere, but again, if you don't have a bender, just do the same sort of trick. Hold it against something of suitable diameter, and you won't really know what's a suitable diameter till you try, like so, and then poke that through. So we'll do a little bit of a zoomy zoom, and then we have to figure out where the 3.3K is. It's right there. So we're going to post that in, and we could do it as you go along. So if you are going to do it as they go along, unlike me, get your soldering iron on. And we can plug that in. And if you don't have one, I quite like these. These are the, I don't know what they actually call them. They've got different names, but TS101. That's what it says on it. So that's probably what it's called. Some are clones, so your mileage may vary. Just see what you can get. Whoa! Dropped it on eBay. Now I'm going to flip that over. We're going to do some proper bottom end soldering. I do actually quite like soldering from the top when I make my own boards. And just as a little bit of an aside, I do have quite a good collection of component legs. Look at that. And that's not all of them. That's just the ones I haven't thrown out yet. That's way too much soldering for someone to be doing. Right, let's have a go. Ooh, yes. That is a nice through-plated via there. Look at that. It's just absolutely gone in, no problem. That means the PCB is nice and clean. And with our tin snips, you can just go in there. Tin snips, side cutters. Go in there and just chomp it off, and there you go, ready to go. So just rinse and repeat for all the other LEDs. So they're saying really do the 220Rs, which we do have 9 of. So those are the 220Rs, and just post those through. So I'll just get on with that. They're in and ready to be soldered. Nice and neat. Let's do that. Flip them over quick. So I didn't use a bender. I just did it by hand. So that has the pleasant side effect, if you see how it's done it, of making the legs cross over under their own tension, which, as you saw when I flipped it, means of course you can flip it without them jumping out. So that is actually quite handy. So don't worry if you've not bought or 3D printed an appropriate piece of bending apparatus, because you don't need it. And in many ways it's better to do it without, I think, because when the apocalypse comes we'll all have to go back to doing it the old-fashioned way, like we did in the 60s. Look at that. It's going on amazingly, by the way. If you are choosing a soldering iron and you're not sure what to get a chisel tip like this. It's like a little sharp chisel tip, and that will let you do all sorts of fun, crazy soldering flowing. And you can just flow your solder straight into the joints. It's absolutely brilliant. I'm never going to go back to a pointy soldering iron, I can promise you that. That didn't take any time to place and solder. I have to say, for a through-hole kit, you're going to expect it to be tricky and a bit fiddly, but this really isn't. Resistors are no problem. It's because all of the components in this kit are virtually the same height or uniform heights as you're going through these layers. So as long as you can just spin them around quickly, so we'll start experiencing that when we do the LEDs, because they're going to be more likely to fall out, you'll be okay. And you can see actually I did just so quick I forgot to solder one of those legs. So after this I think we're going to chuck in the capacitors. So let's get those ready. So we have two C2 and C4 are the 224 picofarads, and they have a 224 written on them, so that's fine. You just got to locate them. So there's 224. Get it in right there. It's a bit on the tight side. I shall just come out. That's it. If it's tight, it's tight. What can you do? And there's another one. C4 is right here. And C6. So you can see these are, of course, the ceramic capacitors. And the electrolytic capacitors, I'm guessing, are starting at 1 because we haven't had a C1 here. And there's another ceramic. So where does this one go? What did we say this one was? 104 picofarads. Oh, right there. Poked through. Now, you can see these aren't actually uniform heights. When we flip them, we actually lost that ceramic one right there, the little one, our C6. But I'm fishing it out, that's fine, can't escape. But if in doubt, just solder one leg. And in fact, I'm just going to do that. Just solder one leg because you've still got the option to then rework it, and that's absolutely fine. So you can flip it over. You can see actually, oh, they're all a little bit on the wonk. So I'm just going to, that one's okay, but let's say we're going to adjust this one here. So I'm just going to hold it on the back, apply the heat, give it a little wiggle. Feels about right now. There you go. It's not too bad. And then this guy has gone crazy. And actually, you can see the solder's wicked through to the top. And if I put some gentle pressure from the top and heat it, I can actually push it down. Look. Now it's tacked in, won't go anywhere. Flip it back over. And finalize it. Make the commitment. Sign the contract and seal the deal. Okay, those are in. So the instructions are suggesting that the next stage is to do the LEDs and not just do them one at a time, but actually, or even a row at a time, just insert the whole lot. So remember, long leg positive. And I'm going to zoom in so you can see quite clearly there's a picture of the LED and it has the long leg positive right there. Okay, and do it again. Long leg positive right there, and you'll know on LEDs when you look at them, oh, that one's not going through for some reason. Okay, on LEDs, if you look at them on their side profile, they've actually got a way. So the anode and cathode are a different shape inside the LED. No, it's not quite clear, but just look at an LED you've got lying on the desk and you'll see that they have a way. So even if you've accidentally gone through and chopped off the LED's legs too short, and now you don't know which is the long leg, just compare it to one you've got on the shelf. I think that'd be the easiest way. So I shall poke these through. I haven't counted them, but how many are we talking about? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 9. Now, I don't remember my math, so let's see. 9 times 9 is basically the same as 10 times 10 minus a few numbers. I want to say, is it 81? Let's just keep going. Just hope they've got enough. That's the only maths we need. I have to admit, I'm not really having this much fun doing this. It's surprisingly long-winded for something that's so simple. I guess it's just a lot of operations, but I can give you some pearls of wisdom. So I post them through and I pivot it around the long leg till the negative terminal lines up, and you can just do that. And then I give it a little wibbly wobbly just to seat it while I'm working on finding the next one. And that seems to be okay. So I'm just toying with the idea of what would I do next, and I'm looking in the instructions and they're putting in the transistors, and I would say that would be the most sensible next step. However, if you wanted to put this IC in, I think you could. It's tucked out of the way, won't affect anything. Not like this one here, right in the middle. This bad boy. Right, almost there. Given the choice, I think I would probably consider soldering them in row by row. Like literally solder a row, cut the legs and keep going. Look, you got 4 spare. Nice. because, and you'll see now, I think we're in with a sea of legs, and a sea of legs akimbo. I'm just befuddled trying to figure out how I'm going to turn this around. I have this weird little pad thing, so I'm just going to do that. In fact, I'll keep it on the pads, and you can see even as we're pushing it, you're going to have to push it right down, because you want them to sit flat. I don't think it's optimal. Again, maybe row by row. You make your choice. I'll probably be able to give you a bit more of a judgment on this once I've done it. Yeah, I'm really not sure how much pressure. You can see even if I put pressure on this one, the far ones are trying to lift off. It's going to be problematic. Maybe it's this. Just take it off that. Oh no, 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 no. Oh, you... even worse. So I tried to use something thinner. Apparently, even that doesn't work. I have no idea what they expect you to do. I would suggest if you've got one of those foamy pads, I think that's probably your best bet. But, you know, I'm just going to do them one at a time. Life's too short. Just do them right. Take your time. Just practicing your solder after all. I'm going to solder these two and chop the legs and move on. I may be some time. As predicted, a UMON can do a row at a time, and that's quite manageable. So yeah, do that. Maybe they're expecting you to use a wave soldering machine. And it does give you the opportunity to check it. Look, I've got one slightly wonky one. Again, same technique as last time really. Just tack one leg before you go nuts. Just gives you the opportunity to make those little course corrections. Yes, that is the technique now. Write it down on a tablet in stone. Row by row is where it's at. It almost feels sad, like the end of a long journey with a nice companion who listens to your stories and just gives the odd murmur of approval. Now I've developed a new skill, and that's of course putting in LEDs in a row, 9 at a time, and soldering them. I'm not sure if it's transferable in the real world, but you never know. It could be something to fall back on. You can see I'm getting quite quick at this. So get that off. And I was really blasé. I even dropped some LEDs earlier and I didn't even bother to pick them up because I knew we had spare. So look, I just give it a little jiggle, make sure it's grounded. And because I have that chisel tip, yeah, I can actually solder 2 pins at once. Huzzah! And that does make things that little bit quicker. Whoop, there we go. You do want to make sure they're still properly soldered. You don't want speed, you want efficiency. Now, while I'm cutting this, we can ponder our next moves, and I think it's going to be the old transistors. So we'll just get rid of those last legs. Boom, that's looking good. Now we had transistors, and earlier we said they're all the same, which is good. Now the footprint, ooh, this is nice, have a look at this. So you can see the footprint is, I can't remember what it's actually called, but there's lots of flavors of transistor footprint normally when you're in CAD packages. And this one's designed to cause the legs to splay slightly, which means they don't fall out. So really just go around and poke them straight through and you'll see there's many to be had. So I'm just going to go and chuck them in. Now be careful and make sure you put them in the right way, because I almost put that one in the wrong way. You can see the top of the transistor is a D shape, as is the footprint. So if you make the D match up, then your base collector and emitter will all be in the right location. And don't always assume that if you're using an unfamiliar transistor, for example, don't always assume that the base collector and emitter will be in the same places that you're used to, because I do find them jiggled around sometimes. And it's the same with power regulators, because you always had like input, ground, output. Very sensible. And then occasionally you'll get a different flavour, and it could be output input ground or output ground input. It's just madness. Oh, ground input output or ground output input. For those of you at home who've made a truth table to figure out all of the combinations, please feel free to leave that truth table in the comments for future reference. Now I did notice a little bit of a gotcha here. So if you see those resistors on the right hand side by me thumb, those Ds are the wrong way round. So they're not really a D, they're more of a wrong way round D, because we don't really have a letter that way. It's like the belly of a small D. That's what it is. It's without the longy bit going up. And if you're not sure what I mean, I shall zoom in momentarily when I have a free hand, because unfortunately AI has not got to the point where it will operate my camera. As you can see, the D, the backwards D. Again, suggestions down below on what we should call a backwards D. In my head I was trying to pronounce the D sound, duh, and then think, what would that be backwards? Duh. I have to do that using editing. Right, so we seem to have a spare transistor. Obviously the kit manufacturers had money to burn, be able to give you spare transistors. In the olden days, transistors were proper expensive. Think of them like microcontroller costs. You'd definitely not get a free transistor if they could help it. I didn't count them. Right, now, so that's them all in, and we'll see if they stay in place. Yes, they do. Phew. After all that telling you about how that footprint was great for that, it would be quite alarming if it didn't work out. Now, by the way, if you've got one of these soldering iron, mine seems to have a weird issue, whereas it's set to 300, but it doesn't mess around. I think it goes to sleep when you put it down. Anyway, right, transistor time. So just pretty much the same as the other stuff, but I would just say don't dilly-dally. I mean, they could be a little bit more sensitive than the passive components we've been dealing with up to this point. So passive components are your resistors and whatnot, whereas these are more active components and they have more fancy innards. How about that? That's basically, they've got more fancy innards, and the fancy innards don't really want to be bathed in heat for too much. I'm having trouble getting some of those pins, so just to keep them tacked, I'm just going to go around, just hit the end legs on those, because I'm going to have to go in deep with my soldering iron to be able to get to the other pins. And I really don't want them jiggling around while I'm doing that. And you can see it's a quick job, it's not going to take particularly long. Right, now let's get the row. So that's these ones right here. You might just see I've only done one leg. Got a bit of a sea of pins, you see, to get through. Now we've just got the middle leg, so I'm going to try to get in. I'm doing it, but I'm not digging it. Come on. Just make sure we didn't short those two. We did not. Good. I think we're almost on the final home straight here. Now check your side cutters out. I've discovered recently that different side cutters I've got cut varying levels of closeness to the board. So some will leave quite a big stub, and others will leave a pleasantly small stub that's less likely to catch you when you run your finger over it. I mean, functionally there's probably not too much in it. Now I did forget to solder a few more pins. Another 4 more to do here. I guess they're super hard to see on camera, but they're here. There we go. Now, the next will be some ICs. That's really what we've been waiting for. That's the real deal. So we want to put in our U4 up here. Now there isn't any sockets, so we're going to have to be a little bit careful. And you can see that the legs are that bit splayed. We're trying to put them in, but they are a bit splayed. So I'm just going to push them onto the bench and just bend them ever so slightly. Don't go nuts with that. You don't want to really stress them too much. You can see that just popped straight in there. Now what I tend to do in things like this, I'll get my pot of just a little cup thing, party cup, and I pop something like that on top of the party cup, and what I will do is I'll tack solder some of the legs from upstairs, as it were. So one at the front, and if you can get to the opposite corner, which you can in this case, do that one as well. And you can see that will hold that in perfectly. That's perfectly held. Now I can just flip it over. Okay, let's just finish soldering. I was going to do that to all the ICs and do them all in one hit, but we make the rules here. That's absolutely fine. And you can see, remember, ICs are going to be even more like your transistors, where you don't really want to hang around cooking the thing. You don't really need to. Look how quick that is. And it's a bit of a joy, to be honest, because there's no legs to cut off on that. It was just right out of the box. Now, something I didn't mention as I was doing that, of course, look at the PCB. There's a little notch in the picture on the silk screen, and that aligns with the notch on the chip. So yeah, make sure you don't get it wrong. Otherwise, you're going to be in a whole world of pain trying to get it out again. And in fact, that's probably where most PCBs get written off, actually, on the rework, is just trying to remove an integrated circuit. Especially on something like an old retro gadget, because the PCB material will be a bit weak after years of sitting in a drawer and or just being old technology, and it will just literally start delaminating off the board. So we've got our V55 timers, just popping that in. Now really, any chip that has the room you can solder from the top. So LEDs you can't, of course, but the resistors and generally a lot of the capacitors you can. The electrolytics are going to be tricky for that. So it's a pretty valid technique. I've got designs of board where I just exclusively solder them from the top, every joint. So don't feel bad about doing it. There's certainly no right or wrong of it. We're not doing military grade IEEE certified soldering that's going to go into like a spaceship or a part lung machine. You're literally just doing a light chaser kit from Amazon. This one's really needs the desplaying treatment. Perhaps we should cut ahead. That would require editing. Don't want to do any of that. Had to get down to 2 hands because this one is being a bit tricky. Alright, there we go, finally. And we're going to do our top solder technique on that as well. And just to show you, actually, you can do all the pins that way too. We just tacked 1 or 2 pins on the previous ones, but this one, you can actually just solder them in. And that will be electrically the same, as long as all your, I'm going to call them pinholes, but they're kind of just like through-hole wires basically, are through plated. That should work fine. And then sometimes when you turn them over, you'll see the device actually has all the solder on these pins on the bottom anyway. Just a couple to touch up. Okay, let's just solder that last one. Actually, last two. You could try to drag solder. Yeah, you can. I'd say it's more like a linear feeding. That works. And that last time again, I'm just going to do the pairs of pins at a time using our chisel tip on this one. So you could do all sorts of, have a bit of fun with it, just have all sorts of techniques. You can develop your own special techniques. So that's those. Next is the switches. We've got a bunch of those. Are they weighed around? So there is a mark on the bottom. So you've got to be a bit careful. There is definitely a mark on the bottom, which is a little notch. In fact, you're not going to be able to see that, are you? Nope. But you can see here when it does eventually demus wherever you're focusing. Well, it's still unfocused, but you can see there. See that little notch on the bottom? Yes, that's all you need to know. There is a little notch on the bottom, and I can see a corresponding little notch on the pictures. So we're just going to hope that all aligns. Otherwise you'll have a lot of switches to take out, and those are probably even more annoying than the integrated circuits, because they'll have mechanical bits inside that will melt. And there's one more down here for power, so that's all four. Now again, we've got that trick now of when we turn it, these are all going to fall out. So there's another way I've done stuff in the past. Let's see if we can try it, where you hold a board at an angle. I don't think it's going to work so well because those things are rocking. So I'm going to see if I can do a tack from underneath. Now that's going to be pretty impossible to film. Let's see. Yes. So that's that one. Yep, that one's done. Let's do this next one. So basically what I'm doing is I'm putting a blob of solder on the iron and then offering it up to the base of the pin on the junction where it goes through the PCB, in the hope that just a touch of it will wick up, because you don't need much and you don't need many pins, just one pin would be enough if you can find one. And here we're on our last one we're trying that with. Yeah, so those are actually all tacked in. And they're not very pretty, but we fix it when we do this next page. So now you can see them all. And you can see this left, it's got a bit of a mess, but we're just going to go for the fresh pins. And then while we're at it, you see we just touch up the ones we previously did, and that fixes them all up, so you don't really have too much effort. And all while you're doing that, the device is held quite nicely in place. And we're just going to do that, it's going to do that. Oops, let's clean that one, there's a bit too much solder on those. Yeah, it's okay. And if you do want to just go through one at a time, you can. You can always just touch them up and then you can see if there's any kind of meniscus forming and bridging between two places that you don't want to be bridged. So that's our switches, they seem to be operating okay. Didn't damage them. And we now have this power socket at the bottom. Again, tricky one because it is definitely going to fall out. So I'll try you another technique you can use on similar things, is basically flip it over, and while you're holding it with your finger on the other side, take a flat of a tool like this tweezer base and you can bend the pins. So you can see there the pins are actually splayed and that holds it in place. Now PCB manufacturers did used to use this technique, so if you open up any old Texas Instruments devices, all the legs of the devices like that were bent over, and it's incredibly tedious to take them apart, but they did that so that they wouldn't fall apart in assembly, and clearly they worked. So we're down to these potentiometers. Now I haven't put in any electrolytics yet, so I'm wondering if I'd missed a stage. Studying their instructions, I don't really see them. Oh yeah, no they did. When they were putting in all the other capacitors, we should have put the electrolytics in. Doesn't matter. Well, we should probably put them in before these because these are really tall, but let's not bother. We're going to go nuts. These remind me of the little potentiometer switches you get on the pocket operators. If you've got a pocket operator or not, but they're good fun. Now again, a prime candidate for top soldering here, because you can see either side of those potentiometers is basically an anchoring point. It's connected to the ground, inverted commas, of the chassis, but it's so big and unwieldy you can get in there and that will actually hold them in. And if you really want to go bolt and braces, do the other side too, and that potentiometer is not going anywhere. That's pretty much as almost as soldered in mechanically as you can get. So when you flip that upside down, you'll have no problem. And you can see those big old lugs there on the bottom sitting half filled with solder. But what I will do, once I've finished soldering, I'm going to go in and really go to town on those, because those are the main part of the user interface. So if you're doing this and it's like an amplifier or something, and you've got a big knob on it that you're likely to be cranking on, I always like to do that just to make sure that it's really secure and effective. Remember, if soldering, you're brazing it, you're not welding it, you're brazing it, and the more meat the merrier, basically, because you're not bonding not fusing the metals, you're kind of gluing the metals. So the more surface area for your glue, the better. Right, so we're down to our last 3 capacitors, and I'm just going to have to kind of guess it. Right, so we've got C1 220 microfarads, so that's this big one, and there's a plus and a minus, so you can't really get that wrong. They seem to have it mounted on the side, so I'm going to bend that like that. As you can see, I've bent it over so it's sitting flat. I'm going to top solder that in a second. And then you have C5 in there, and then C3. We are almost good to go. It's actually quite worrying, isn't it? And make sure you're long leg positive. So the shaded part, by the way, is negative. And if you look again, we'll take C3 out. See that bit on the right hand side where it's got a cross hatchy shady thing? That is the negative. Let's just get this. Oh, it's quite heavy now. This is good fun though. 12 quid, isn't it? That's not bad. Right, so I've got that one tacked in now from the top. It's cool. It's just got these to worry about, because these could drop at any time. Right. Now, if they're all in alignment, this one isn't. I was going to say, if they're all in alignment, I just chop the legs and I'm done, but clearly this one had other plans. I'm going to check them all a bit more critically. No, that's fine. Right, we're good to go. Let's clean the bench. We can put the soldering iron away. We are ready to power up. Instructions in the bin. Just take out that USB cable, and it's a decent length. I'd say it's must be at least 60 centimeters, maybe longer. That allows me to plug it in elsewhere on my bench with ease. In it goes. Oh yeah, nice. That is actually pretty cool, isn't it? So the left seems to be adjusting this vertical, and what you're noticing, right, every time it gets to the end, it is incrementing up by 1. And do you remember we had a thing here where the output from one is connected to the other, right? So I believe that's what we're seeing there. So no matter how fast, you can't slow it down basically, so it never increments, put it that way. Yeah, so it's always, this is really adjusting the speed of the pulses to that timer. And then the other one, what does that do? Oh, it doesn't seem to do anything at the moment, so let's speed it up. No, it doesn't seem to do anything, but that's what these other switches were for. Oh, there's loads of switches. Oh my gosh. Right, I might have to think about this a little bit more, but let's slow it all back down again. Right. So this left-hand switch seems to really be playing with the speed, doesn't it? So when it's in, well, rather when it's out, it's going quite slow, and then when you push it in, it goes a bit faster. Let's put it back out to the slowest speed, so you can see it scanning. So that's at the maximum speed. You can see it scanning, right? And then when I push it in, it's almost waves because it's going so quickly. So that's fine. So that's what that one is. Now the second one, don't know what that does. But let's see, that could be a modifier for this one, which is definitely the XY adjustment. And it is. So this adjusts the speed of the y-axis. So now you can. So this is the x-axis speed. This is the y-axis speed. So you can see now that's going all over the place. And I guess it would probably be some sort of a triangle wave if it was a little bit more obvious that what it was doing. That's cool, isn't it? Look at all these weird interactions. I mean, this could be quite fun if you've got an oscilloscope, so you could see also what it's doing. I mean, that's kind of, no, I was going to say it's kind of like what an oscilloscope does, but it's not really. So I kind of feel that's pretty much it. We could just keep playing with it and making all these nice patterns. I think next thing would be quite nice would be to actually just put it in a little case so that you could fiddle with it. Something else that would be possible is probably to have a microphone input with a little op amp, and based on sound it could change this pattern too. Not really sure what kind of interesting patterns. You had it like doing that way diagonally. Now I'm wondering if you can do it that way diagonally. I think that might be an impossibility because you can only rotate it so far. Yeah. Oh, but we do have that combination of the speeds on each axis that's separate. Who knows? Yeah, it's fun. It's a lot of fun. You can see here actually on the diagram switch 2 and switch 3 they actually changed the capacitance of this pin 2 on the 555, and I think based on how long it takes to charge or discharge these capacitors, that's operating as the timing circuit for that. A bit like a resistor capacitor oscillator. Now looking here, this switch 4 though, that's bringing in that vertical component, you can see I can't really tell what it means actually to be when it's switched, because if we have it switched to its current position there, you can see it's getting this output from this channel 11, which will be coming around here. And then if it's switched here, I think it's just, does that mean it's just getting a steady pulse from the oscillator? Anyway, answers down below, my learned friends. So hopefully that's been of some use to you. Please comment down below. Come join me on Discord if you want to chat about stuff, or look at www.backofficeshow.com and see if there's anything in the shop you like. And many thanks, of course, to my lovely loyal patrons. Without you, these bits of tat wouldn't be able to live on my shelf of doom. Thank you for watching.